Hello, everyone. I would like to welcome you to my talk for this International Conference on Second Language Studies. My study is titled How Do Second Language Learners Write? Observing Writing Behaviors and Input Log. Now, this is me, and this is my biography. I currently work at the University of Murcia and at the Atlántico Medio University. I'm an associate professor, and my research interests are very varied, but mostly second language writing and writing process research in digital environments, which is what we are going to be focusing upon today. Writing plays a central role in academic success and second language development. Yet, we still know relatively little about how learners actually write moment by moment. So, Keystroke logging tools like Input Log help us observe these writing processes as they unfold. In particular, we can look at pauses, not just as moment of silence, but as traces of cognitive activity, planning, formulating, revising. However, and that's something very important to take into account, much of the existing research relies on fixed pause thresholds, like saying any pause over 2 seconds must be planning, formulation, but that kind of rule can be arbitrary and sometimes misleading. So in this study, we propose a different approach, a rule-based classification system that combines pause duration with location and writing context, all grounded in cognitive theory. Um, so our approach builds on several well-known models. First, Flower and Hayes described writing as a recursive process where planning, translating, and reviewing work together continuously. Hayes later added components like motivation, goals, and self-regulation, which are essential for managing some writing decisions. And Kellogg focused on working memory, arguing that cognitive load affects how writers balance planning and fluency. And eventually, Galbraith proposed a dual process view, separating fluent text generation from more reflective, effortful revision. Now, all these models help explain how different subprocesses unfold and interact during writing. Now, in writing research, pauses are often used as indicators of cognitive effort, as mentioned previously, traces of cognitive effort. But the way they are interpreted has evolved. Early studies use fixed thresholds, and some of the current studies as well, like 2000 milliseconds, to define planning. But this approach, to my view, oversimplifies what's really happening. And as other authors have pointed out, a pause isn't necessary planning, especially if we are ignored the surrounding context. Duration alone is not reliable. And more recent work by Hall and colleagues shows that pause function depend on where the pause occurs and what kind of action follows it. So what is actually needed is a theory-based system, right, that considers both duration and location and links them to specific writing processes. That's what interests us most. Now, keystroke logging, like input log, allows us to observe what is writing as it happens. So they capture insertions, deletions, pauses, and cursor movements. And it provides us with high temporal and spatial resolution, which gives us real-time process data. Now, the problem is that post-interpretation has been inconsistent. Many studies use raw logs without a clear theoretical framework. That's why recent work by Hall and Konyich has called for automated theory-driven classification where pauses are analyzed based on both context and location, not just duration. Right? This is the gap our study addresses, and we attempt to add more empirical evidence to this line of inquiry. Now, so the aim of this study was to develop and apply a method for identifying writing subprocesses in real time. And we focus on three main components of writing: planning, formulation, and revision. Now, our system uses input log post data, combining duration and structural location to classify each event. So based on these, we ask three different research questions that guide our study. First, when do differing subprocesses occur across a task? This looks at their temporal distribution from beginning to end. Second, how is post location related to subprocess type? In other words, are certain processes more likely to happen at specific points in the text? And the third one is how frequent and how long are pauses in each subprocess. So this gives us a descriptive profile of how each process behaves in terms of timing. All right. Now, um, moving on to the context and participants, the participants were 16 Spanish-speaking university students who were enrolled in a primary education degree. Their proficiency level ranged from B1 to C1 based on the Oxford placement test, and their mean age was 19 and a half. And most had limited experience with academic writing in English. Now, the writing task was a timed argumentative essay with 35 minutes to write at least 200 words. The topic was, as you can observe here, education and cultural exchange, and no external aids were allowed during the task. Now, this controlled context helped us isolate process behaviors while keeping the conditions realistic. All right. So this is the overall picture of the context and participants. And now we're going to look into the research design. Now, the writing task was a timed argumentative essay, as mentioned before, completed in 35 minutes without external aids. The entire session was recorded in input log 9.0, which is the latest version of the Keystroke logging tool developed by Van Vaj and Leighton. Participants worked in Microsoft Word 2021, and all their keystrokes, including pauses, deletions, cursor movements, were logged automatically. Now, this setup gives us a high-resolution data that we could then classify by writing subprocess and structure. Well, to classify each event, right, and this is the novelty that I'd like to bring in to this presentation and this study, we developed a VBA script that parses the XML logs exported from input log. Now the system labels each event, pause, insertion, deletion, as part of a specific writing subprocess, planning, formulation, or revision. Now it relies on three main criteria: pause duration thresholds, pause location in the text, right? And cursor or keystroke behavior. Now these rules are drawn from prior research, including Hall et al., Marie Morek and Briscoe, and others. Now, the logic is recursive, meaning each event is interpreted based on what came before and after, so the system builds context as it goes. Now, this allows us to apply consistent theory-informed tagging at scale. Now, here you got an excerpt of these VBA code and VBA script. And obviously we had more time. I would have loved to show you what the output of the VBA code is when parsing those logs, right? Now, but we're going to see the outcome in reality in terms of the data. So based on the classification system, right, we tracked three main writing processes: planning, which we divided into global and local; formulation, which includes fluent writing, lexical retrieval, and problem solving; and revision, split into subword, word level, and above word edits. Now, for each subprocess, we extracted several measures: the total number of events, pause per minute to estimate density, main pause duration in milliseconds, and pause location patterns based on structural position in the text. We also calculated each subprocess's share of the total writing time and how it was distributed across three time intervals: start, middle, and the end of the task, right? To address each research question, we use different statistical tests. For the first research question on how writing subprocesses unfold over time, we use Friedman tests to compare distribution across three intervals, along with Kendall's W for effect size. Where relevant, we also ran Conover post hoc comparisons with home corrections. Now, for the second research question, which compares pause frequency and duration across processes, we ran Kruskal-Wallis tests, right, followed by Dunn tests for pairwise comparisons. We also reported epsilon squared with confidence intervals. And for the third research question, we examined, right, the relationship between pause location as a process type using a chi-squared test of independence, along with standardized residuals, Cramer's V, and the contingency coefficient to interpret the strength of association. All tests were run in JASP, and the classified data came from input log XML logs, parts with our custom VBA system. Now, let's start with the first research question: how subprocesses are distributed across a writing task. Now, the line graph shows the percentage of time, right, devoted to planning, formulation, and revision across the three intervals: beginning, middle, and end. As you can see, formulation stays remarkably stable across time, just under 18%. Planning fluctuates a little bit, with a dip in the middle and a rise in the end. And revision remains low throughout, right, with a slight drop in the final third. And the statistical tests confirm this pattern. The Friedman test found no significant changes across time for any microprocesses. And for revision, we see a slight trend, but it doesn't reach significance. The bar chart gives a breakdown by subprocess, as you can observe here. And for example, local planning increases in interval 3, and problem-solving formulation is slightly more active in the middle. But again, no changes are statistically reliable. And the process overall, I think, remains stable, suggesting the writers keep planning, formulating, and revising in parallel throughout the task. And this has important implications we will discuss afterwards. Now, moving on to the second research question: do pause frequency and pause duration vary across writing subprocesses? Well, we ran Kruskal-Wallis tests, and we found strong significant differences for both metrics. For pause frequency, the test was significant with a large effect size, and for pause duration, results were again significant with an even stronger effect. Now, the bar charts, I believe, help illustrate this. Subprocesses linked to revision, especially above word and word level revision, showed very frequent but very short pauses. These suggest obviously intense, quick bursts of activity. In contrast, planning, especially global planning, involved much longer but less frequent pauses, consistent with heavier cognitive processing. And formulation here falls somewhere in between. Fluent formulation shows brief, infrequent pauses, reflecting more automated production. So we see a clear trade-off here: high frequency and short duration for revision, low frequency and long duration for planning, right? So moving on to the third research question, we wanted to know whether the location of pauses could be meaningfully linked to the type of writing subprocess. Now, this descriptive heat map shows the percentage of pauses within each subprocess, broken down by structural position in the text. There are a few patterns that stand right away. Fluent formulation shows a high proportion of pauses within words and after words, and this supports the idea that these are mostly micropauses during ongoing production. 100%, well, in contrast, global planning and lexical retrieval pauses tend to appear before words, which makes sense if we consider those involve anticipation before committing the text, and also afterwards. And 100% of the pauses as well were linked to revision, right? Which is an important thing to consider here. To test whether those associations were statistically meaningful, we ran a chi-squared test on pause location by subprocess. The result was highly significant, which with a Cohen's V of 41, Cramer's V, sorry, which suggests a very strong association. Now, let's focus briefly on the most prominent, right, standardized residuals, right? So fluent formulation, right, well, revision, mostly, are clearly tied to the revision zone, right? So above and word level revision were clearly tied to the revision zone, revision pauses, away from the insertion point. Fluent formulation is strongly tied to within word and after word pauses, meaning that those locations were overrepresented compared to chance. And planning and lexical retrieval shows peaks before words, indicating conceptual load before inscription. So as we can see these results support the idea, right, that pause location is not random. It carries cognitive information and can help identify the type of process which is involved. So what do we take from the temporal data? Well, there was no significant interval effect. That means participants didn't shift gears between thirds. So they kept the same cognitive mix, planning, formulating, revising all the way through. And the flat line, this flat line is telling, it supports the idea that writing is not a stage process, but a parallel one, especially under time pressure. That fits well with Flower and Hayes' view of writing as recursive and with Galbraith's dual process model where planning and production unfold together. Even more interesting is that planning wasn't front-loaded, not even global planning. It kept appearing mid-task, which reflects how second language writers manage high-load tasks. So instead of doing all thinking up front, they break it up with what Kellogg called chunked planning and spread it across the text. So that pattern has also been seen in prior second language studies like Dilemmas, showing that less experienced writers were conceptually on the go, right? So what do these pause patterns tell us? Let's start with revision. It involves lots of very short pauses, basically a form of surface tinkering. So you see rapid edits, cursor jumps, and tiny delays. So this matches Barkowitz' idea, right, of low conceptual, high monitoring behavior. Now, global planning showed the opposite. It was rare, but when it happened, the pauses were long, around 5 seconds. So that points to macrostructuring and deep retrieval, as noted in Wengeling and Sasaki's study. And in between those two, we had problem-solving formulation. Pauses around 2 seconds, right? These seem to mark the moments when fluent production breaks down for repair, and that supports Galbraith's dual process model of writing. So when we look at pause locations, we see distinct spatial patterns tied to specific subprocesses. So fluent formulation, for example, is marked by pauses inside or right after words. And these micro pauses, 45% within word, 34% afterward, they match with Chenoweth and Hayes and Medimorek and Risco found for low-level inscription. They signal fast, automatic lexical motor encoding, not heavy thinking. Planning and lexical retrieval, in contrast, tend to pause before words or even paragraphs, and writers seem to, hold just before committing, probably to organize ideas or find the right word. And these patterns line up with Wengeli and Sasaki's et al., who show how planning clusters as structural boundaries. Right? And finally, all revision activity was located in what we call the revision zone, 100% of those pauses. And these align with Lingering and Sullivan and Hall et al. Evaluative editing, which typically happens away from where the writer is currently producing text, which actually makes sense. So what do we take away from this? Now, first, so processes stayed active in parallel throughout the task, and this supports recursive models and mirrors previous findings in novice second language writing. Second, we observed a trade-off between pause frequency and duration. So planning pauses were long but rare, and revision was dense and fast. So this pattern matches what other colleagues have found in argumentative second language writing and reflects load-sensitive timing as described by Medimorek and Risco. Third, the location of a pause was highly predictive of the underlying process, and this supports more context-aware approaches to pause analysis and challenges the older duration-only models. And finally, the method itself is a key contribution. The VBA system paired with input log produced some results similar to manual expert coding, but at scale. And that opens up, I believe, an affordable, replicable process research, right? As it has been suggested over a decade ago. Now, we have a series of limitations. We had a small sample size, which limited generalizability, of course, also because participants were university students in specific contexts, so findings may not extend to other second language populations, children, professionals. No product process link, so we didn't look into the correlations or the link, the relationship existing between process data, writing processes, and text quality, for example. We only use one test type, argumentative essay only, and focus on input log only logging, which means that we should have focused a little bit more on triangulation with screen capture or retrospective protocols in order to delve deeper into those processes. So there are a series of suggestions in light of these limitations. First, we should enlarge the small sample size. So we should also try to enlarge the population on which we are going to center those studies. We should also look into into textuality. We should observe how individual differences, for example, influence the writing process together with the product, the written product. We should use other future research should use other tasks such as opinion essays or even stories and multimodal tasks. And we should rely on other data gathering techniques such as, think aloud protocols or even screen data that may shed light upon important information related to writing processes. So with this, we finish the presentation of the study, and I'd like to thank you for your attention. If you have any questions, just feel free to contact me. Thank you very much.